So number 13, the constructors in the rational class allow initialization of rational objects in several different ways. Which of the following will cause an error? So rational R1 equals new rational, seems fine. Rational R2 equals R1. I mean, if you're taking them in that order. Rational R3 equals new rational 2 negative 3. Seems fine. Rational R4 equals new rational 3.5. And rational R5 equals new rational 10. So we go up here and we check the constructors. So you can construct an int or a numerator denominator. So that looks fine. That is not an int. It's a double, so that one will cause an error. D will cause an error. Okay, 14. Here is the implementation code for the plus method. So just gives you a little comment, return this plus r in reduced form, and leaves this unchanged. So public rational plus rational r fixed signs, and r dot fixed signs. Int denom equals mydenom times r dot mydenom. Int num equals mynum times r dot mydenom plus r dot mynum times mydenom. So this kind of just does the math of adding two rational numbers together. So a correct replacement would be A, rational rat, num denom, rat dot reduce. So you reduce your rational number that you just created, and then actually, yeah. So all the math is done here. Unfortunately, it didn't use the constructor correctly. So that's an easy thing to miss. It has to have rational rat equals new rational num denom, like that. So we'll just look down here. So this is the same, except it uses the constructor correctly. So D is the answer for 14. So if we assume these declarations, rational A equals new rational, rational R equals new rational num denom, int n equals value, so num denom and value are all valid integer values, which of the following will cause a compile time error? So this is something that the compiler would catch before you ever got to run your program. So in D, int, which n is an int, does not have a plus method. You're trying to call plus on an int, and that just doesn't exist. So that's a compile time error, because the compiler will check around to see if int has a plus method, and it doesn't, so it'll spit a compile time error back at you. So 16, here are the private instance variables for a frog object, public class frog, private string mySpecies, and so it just gives a bunch of private variables. So which of the following methods in the frog class is the best candidate for being a static method? So this is 16. So it would be B, because the temperature is not specified in one of these, so it's not considered like a variable. It's just going to be like, oh, it's always 32 or something like that. So B is the correct answer for 16. For 17, what output will be produced by this program? Public class mystery, public static void strange method, int x, int y, x plus equals y, y times equals x, system.out.println x plus space plus y. Public static void main string array args int a equals 6, b equals 3, strange method, system.out.println a plus b. So right here the correct answer is E, and this comes about because it's not like ints aren't transferred as references; they're transferred as values. So yeah, we'll just go through it and you'll see. So 6 and 3, and we do 6 and 3. So 6 plus equals 3. So 6, 9. Y times equals x. So 3 times 9, 27. So 27 and 9. So 9 and 27 are printed out here, but the thing is that never gets back to main because these aren't, like, the integers aren't references. These are whole separate objects from these. So yeah, E is the correct answer. For number 18, we have another class. So public class temperature, and it has a scale and degrees. Okay. So a client method contains this code segment. Temperature T1 equals new temperature 40 in Celsius. Temperature T2 equals T1. Temperature T3 equals T2 dot lower 20. Temperature T4 equals T1.2 Fahrenheit. What statement is true following execution of this statement? So this is number 18. And B, because of references and how they work, so you construct one variable, but you only ever construct one. So you're changing this reference in many different ways, but it's, yeah, you're changing the one object in all of these in lower 20 and 2 Fahrenheit. So you get lower 20 and 2 Fahrenheit all in all of your variables because they all reference the same thing.